Okay, here we are on day 32. I don't see us counting. Oh, hold on. Yep. Okay, day 32. And I'm going to turn to the math section. Here's my math windows. Okay, and I'm going to get one that I can write on. So I'm going to switch this out. Hold on. And I'm going to go right to here. Math windows. So I want you to read number 1. Try that one on your own. See what you can do. And I'm going to check it with you. While you're reading it over, I'm going to try getting it a little closer here. Okay, how's that? That's good, but that's not number 1. There's number 1. In case you don't have a paper at home, you can read it here. Try that on your own. Okay. Let me see. Okay, an English book comprises of 2 sections, literature and grammar. The ratio of this number of pages is 3 to 2. How much of each type of content will be needed to make a book of 150 pages? Okay, so they have 2 sections, literature and grammar. And there's more literature than grammar. It's 3 parts literature to 2 parts grammar. Okay, so there's more literature than grammar. Altogether, there's 150 pages. Now, you want them to be in a ratio of 3 to 2, but they give you 150 pages. That's the total pages. You have to find out how much of it's literature and how much is grammar, and it has to be the same ratio as 3 to 2. What makes this hard is because you're working with literature, grammar, and total. Okay, so what we're going to do is we're going to take 3 for literature, and we're going to compare it to the total, not to the grammar, to the total. So there's how many parts total? 3 are literature and 2 are grammar. And let's say they're equal parts. How many parts are there? You just add them, 5 parts. So 3 of the 5 parts is literature. The other 2 parts is grammar. This is equal to 150 is the total, so it compares with the 5. We put it on the bottom because the bottom is the total. And we want to know how much would be literature of the 150. So what part of 150 is the same as 3 parts out of 5? Now, how do we solve this? Well, you can cross multiply. We want to get x, right? So basically, we're going to multiply by 150. If we multiply, this is divide by 150. If we multiply by 150, we should get x, because the 150 will cancel. So we're going to have 3/5 times 150 equals x. So you're going to go 3 times 150 and divide it by 5. Or you can do 3 divided by 5 times 150. Either way, it's going to work. What do you get when you do that? 3 parts divided by 5. Okay, well, if there's 5 parts and it's 150, each part is going to be 30. That's 150 divided by 5 is 30. And then you want 3 of those 30s. 3 times 30 is 90. X equals 90. That's how much is literature. To get grammar, you can go 2 times 30, because each part is 30, we said. Or you could go 150 minus 90. So this is literature. Grammar would be 150 minus 90 would be 60. Okay? 60. So 90 to 60 is the same as 3 to 2. 90 to 60 is the same as 3 to 2. Okay. Try number 2. Again, you should be using your pause a lot to pause and try things on your own. If you don't have a paper, you can pause it to read the paper. Okay, you can pause it at any time when I'm doing a problem to see if you can finish it on your own. Okay. Susanna is painting a mural in the foyer of City Hall. Mural is a great big painting. She is working from her original drawing and enlarging the drawing proportionally. So when you make a mural, you might make a small drawing and then you're going to take it part by part and enlarge them to fit it onto the mural. In our original drawing, a tree is 9 3/4 inches. In the mural, the tree will be 6.5 feet tall. In a house, the mural will be 4 feet tall. How many inches does the house measure in her original drawing? Okay, so we're comparing two things, trees and houses. Now, you might think we have to be careful because we're measuring in inches and we're measuring in feet. The tree is in inches and feet. You don't have to convert in this problem because if you think of the house in inches and feet and you do the same comparison, it should work out without having to convert. So we're going to just use the original, it's 9 3/4, right? And the tree is 6.5. Even though they're different labels, inches and feet, we can still do that because we're going to do the same with the house. The proportion from the tree proportion has to be the same as the house proportion when you change them, when you do it on the mural. Now the tree will be 6.5 feet tall in the mural. Now which was the mural here? 9 3 was the original drawing, inches, and this was the mural. So the house mural also has to go on the bottom because we're putting the tree on the top. That's the original, and this is the mural. So we have to do the original, which we're trying to find out. And the mural is going to be down here on the bottom. It's going to be 4 feet tall. There we go. So we compare the tree to the mural. The tree to the mural. Now these are feet, but these are inches. That's okay. Oh, sorry. I compare the tree to the mural, the original to the mural of the tree. These are the trees. So on the house, I'm going to do the original and the mural on the bottom too. Okay? Just got to remember the top ones are inches and the bottom ones are feet. Okay, so how do we solve for x? Well, we just multiply by 4. If we multiply by 4, we'll be left with x. So that means we have to multiply this side. So we're going to do 4 times 9 3/4 divided by 6.5. Okay, problem with this is we've got quarters and halves here. Well, it's not that easy when you work with fractions, okay? You could convert these to decimal. How do you convert to decimal? Well, you could just put 3 divided by 4 to convert to 3/4. But you know what 3/4 or 3/4 is. Well, how much is 3/4? 75 cents, right? So this is 4 times 9.75. And then you're going to divide by 6.5 divided by 6.5. Because 1/2, you could put that in your calculator, but 1 divided by 2 is 0.5. So you got this. Try this and see what it comes up on a calculator. Let me try it on my calculator. I got to get out of here. Well, how am I going to get out of here? You know what? I'll do it on my phone instead. Calculator. Calculator is here. Can you see that? Well, you don't have to see. You have your own calculator. 4 times 9.75. 4. What happened? Calculator. Where are you again? That's calendar. Oh, well. Here we go. Is it clear? Yes. 4 times 9.75. 9.75 divided. Where's the at the top? Divided by 6.5. 6.5 equals. Oh, it says it here. 6. Exactly. 6. So the answer would be 6 feet. Or 6 inches, rather. 6 inches. Because that's the original drawing. So I get 6. X is equal to 6. And it's inches. The original drawing is inches. The house would be 6 inches big on the original. That would make it 4 feet big on the mural. Okay? So if you want to do a tree that's 4 feet big on the mural on your original, you have to make it 6 inches big. I'm sorry, this is the house. The house, you'd have to do the house 6 inches big, and then it'll be 4 feet on the mural. Okay, what percent of 29 is 3? Well, 29 is the whole thing is 29, and we want to know what part of 29 is 3. So 3 out of 29 is represented like that. And again, we have our calculator. I'm going to clear it. Does that clear it? And then I'm going to do 3 divided by 29 equals, and I get 0.10344. I'll put 0.103. 0.103. Now, we want percent. This is a decimal. What part is a decimal? But percent is a special fraction. It's hundredths. How many hundredths is this? Well, that's tenths, and this is hundredths. So it's 10.3. You have to multiply by 100, which means you have to move it 2 decimal places. It's 10.3 hundredths, or 10.3%. It's actually a little bigger than that, but we rounded it to 10.3. Again, you divide. When it says what percent of 29 is 3, you just divide 3 divided by 29, 3 29s. You compare the part to the whole. Okay, number 4 is a nice reading one. Read that one. You can pause it and read it. And I'm going to read it now. Chris, Elliot, Andy, and Dave need to take a test. The teacher can only give one student one test per day. They can sign up to take their test any day, Monday through Friday. How many different ways can the boys be arranged to take the test? So only one can take it on Monday, Tuesday, Wednesday, Thursday, Friday. Now, I'm not sure if they count a day that they don't take it, right? So maybe it's Chris the first day, Elliot the second day, nobody on Wednesday, then Andy on Thursday, and Dave on Friday. Not sure which one they mean, okay? Let's assume that they have to take it. Let's assume we do it that way. That Chris Monday, Elliot Tuesday, Wednesday nobody, Thursday Andy, Dave Friday is different from Chris Monday, Elliot Tuesday, Andy Wednesday, Dave Thursday. Even though they're in the same order, one day they're not taking it Wednesday, one day nobody's taking it on Friday. So we'll count them as different ones. It's a confusing problem. Okay, so in that case, there's 5 possibilities. A day could have Chris or Elliot or Andy or Dave or nobody each day. So on Monday, how many different choices do you have? 5. It could be Chris or Elliot or Andy or Dave or no one. So there's 5 chances on Monday. And after Monday, how many different choices do you have left on Tuesday? Well, there's going to be 4 left because one went on Monday. So you're going to go times 4. There's 20 different ways you can do Monday and Tuesday. But then on Wednesday, you could have 3 different ways. And Thursday, there's going to be 2 left. And then Friday, whoever's left gets to go on Friday. So you get 5 times 4 is 20, times 3 is 60, times 2 is 120 different ways. That's if you count the day off as a unique order. Okay, because the day off could be Monday, Tuesday, Wednesday, Thursday, or Friday. Anyway, there's 120 different ways that way. Now, if you don't count the day off as a different one, then it wouldn't be 5, it would be 4 times 3 times 2 times 1. Who went first, who went second, who went third, and who went fourth. So it would be without the 5, so it would be, what, 4 times 3 is 12, times 2 is 24. There'd be 24 ways. So I'm going to jump to the back and check and see what they put as an answer. If I have it. You know what? I think I forgot to get it. Where's my answer key? Oh, I don't have it here. Anyway, I think the answer should be 120 if you're counting the day off that they didn't take the test. Did you see that all? Maybe you didn't see any of it. I don't know. Anyway, 5 different possibilities on Monday times 4 on Tuesday times 3 on Wednesday times 2 on Thursday times 1 on Friday. You multiply them all, 120 different arrangements. Okay, that's a lot of different arrangements. You could do Andy, Chris, nobody on Wednesday, Dave on Thursday, Elliot on Friday. Or you could do Andy on Monday, Dave on Tuesday, Elliot on Wednesday, nobody on Thursday, and Chris on Friday. There's 120 possibilities of how you could take those tests. Okay? Okay, so we're going to go on to our lesson now. Let's see what we have here in our lesson. I'm going to put this back. Oh, that goes here. How are we doing on our time? Let me see where our time is. Our time, we're up to 15 minutes. We're just barely starting the lesson. Ay, ay, ay. So, we are doing something called inequalities. Inequalities are equations where we use a symbol. Usually we use the symbol equal, right? That's an equality when we do equations with equal. But you can use a different symbol. You can use less than. You can use greater than. I remember them this way. Less than. Greater than. This is less than or equal. It could be equal also. This is greater than or equal. So there's 4 different symbols of inequality. Less than, greater than, less than or equal, greater than equal. And this lesson is about solving problems where we have these symbols instead of the equal sign. We've been doing equations with equal signs. Now we're going to do inequalities, like unequals, okay, where they're less than or greater than or less than or equal or greater than or equal. But the thing is, you do them the exact same way. So this will be good practice for solving equalities, because inequalities are very much like equalities. You follow the same rules. You want to manipulate the equation till you get down to just x equals something, or the variable equals something, to find what the variable equals. But in this case, you're finding what the variable is less than or equal to, or greater than or equal to, or less than or greater than. Okay? There's going to be one special little rule, and we'll get to that as we do our problems. Okay, so you can read through this, read through the examples if you want. I'm going to go right to the problems because we're kind of limited on time. Okay? So I don't want to write on, this is my good sheets. I don't want to write on them because I don't have any more copies. So I made copies over here. So I'll put this on the side. And we're going to go right to some problems. Did I copy them? I think I forgot to copy them. Oh, I know why, because I'm going to do them on the back. Okay, hold on. So I do still need these. I'm going to go to page 32. Day 32, page 8 of 12. Everybody there? Inequalities practice. I'm on day 32, page 8 of 12. And we're going to do some practice problems there. Okay. First one is 3x minus 7 is greater than 5. So I'm going to copy that onto here. 3x minus 7 is greater than 5. So what I'm going to try to do is solve this. I'm going to try to end up with just an x. Okay? So remember how to do these? Just do them just like it's an equation. 3x minus 7 is greater than or equal to 5. That's great, friend. Let's pick this up and then leave it on this. Okay. Did you try it on your own? Okay, here we go. So I want to end up with just an x, right? So first I'm going to get rid of the minus 7. How do you get rid of minus 7? You add 7. If you add 7 to take away 7, you end up with 0, so that disappears. So I'm going to add 7. I'll write it out. Later we don't even bother writing it out. We don't write the plus 7. We just ignore this part. We get rid of it. is greater than, now of course whatever you do to one side you must do to the other, so we add 7 to the other side. That keeps the inequality the same. Here we go. This becomes just 3x is greater than, and this is 5 and 7 is 12. Okay, we got rid of the 7. Now we want to get rid of the 3, and then we'll have x. Now, what we're going to do is divide by, this is 3 times x, so now we're going to divide by 3. If we divide by 3, this will become 3 divided by 3 is 1. We'll end up with 1x, which is x. 3 is, but we also have to divide by the other side by 3. That'll give us x is greater than 4. X is greater than 4. Now later we're going to be graphing our answers, but I'll just show you real quick. If you had to graph x is greater than 4, you look at a number line, and you go to the 4, and x is any number bigger than 4. So I'm going to put a little circle on 4 because guess what? It's not 4. It doesn't say equal to 4. It's greater than 4. So you put a little circle there, and you draw an arrow this way. All these numbers going this way, 4 1/4, 4 1/2, 5, 7, 7 3/8. They're all greater than 4. All those numbers that way are greater than 4. That's how you would graph it. Okay, you see that? Okay. Now we're not going to do every problem, so I'm going to skip 4 problems. We'll go every 4th problem, so we're going to jump 4. So we're on number 1. We're going to jump to number 5. Here we are. 2 times x plus 3 is less than 4. So again, I'm on number 5. If you are following along, number 5. 2 times x plus 3. 2 times, I'll put a number 5 here so we remember. X plus 3 is less than 4. You with me? Okay. Again, I want to end up with just an x. So first I'll get rid of this 2 because 2 is multiplied times both these. How will I get rid of that 2? It's 2 times this. I can't subtract 2. It's not a 2 by itself. It's 2 times this thing. So I'm going to divide by 2, which means I divide the other side by 2. So now I get x plus 3, and since it's by itself, I don't need the parentheses, is less than 4 divided by 2 is 2. Now I want to get rid of the 3. This is adding 3, so guess what? I'm going to subtract 3. I'm not going to write it this time. If I put plus 3 and I subtract 3, it's going to be 0, which means just an x. I got rid of the 3. Now, if I'm going to subtract 3, I have to subtract 3 from this side. 2 minus 3. Okay, so I subtracted 3 from both sides, or you could say I moved the 3 to the other side, and when you move a number to the other side, it was plus here, becomes minus there. X is less than, now what do you have? 2 minus 3. That's the same as positive 2 plus negative 3. A positive and negative, you subtract them. 3 minus 2 is 1, and you take the sign of the bigger one. The 3 is bigger, so it becomes minus 1. X is less than minus 1. Again, if you were graphing, that's the 0. This would be the minus 1. You'd circle the minus 1 and go that way. That was number 5. Now what did I say? We're going to skip to number 9. Let's see. Every 4 I say. Okay. We'll do number 9. This is a big one here. Number 9. You, of course, can try the others. And the answer key is in the back. Again, try these without me. If when you think you can do them, you try them without me, okay? Okay, number 9. X minus 2 divided by 3 is greater than 2x plus 11. Okay, there we go. Now this one has x's on this side and x's on this side. What am I going to do here? Well, this x minus 2 is divided by 3. I want to get rid of that 3 first so that the x isn't being divided by something and the 2 also is divided. So I'm going to multiply by 3. This whole thing is divided by 3. If I multiply by 3, The 3 divided by 3 is going to cancel, and it'll just leave me x minus 2 when I multiply by 3. That means I have to multiply by 3 here. So I'm going to do 3 times 2x plus 11. Wow. This is getting complicated already, right? Okay, so that means x minus 2 is greater than, now you're going to multiply the 3 times the 2x is 6x, but you also have to multiply the 3 times the 11. That's 33. Now I'm starting to get somewhere, right? I can add an x. I mean, I got 6x here, only 1 here. So if I subtract an x from both sides, the x will be gone from here. So I'll end up with minus 2 is greater than. I subtracted an x, so I subtract an x. 6x minus an x is 5x plus 33. Now I got x's already. I got to get rid of that 33, so I'm going to subtract 33. Minus 2 minus 33 is greater than 5x. Boy, this is not coming out good. I got to make sure I didn't copy it wrong. Usually they make them come out nice. Well, this one is not going to. Okay, minus 2, oh wait, maybe it will come out. Minus 2 minus 33. They're both minuses, so it's going to be minus 35. You're at minus 2 and you subtract 33 more. Minus 35 is greater than 5x. And we're going to divide by 5. And that'll make 1x. Negative 35 divided by 5 is negative 7. Is greater than x. X is less than negative 7, or negative 7 is greater than x. Oh, you see where I am? I divided by 5, and I got negative 7 is greater than x. This is the same, by the way, as x is less than negative 7. You can read it this way or this way. Okay? That was number 9. So let's see where we would go. Well, let's see what time we're up to. 27. I think I better stop it there. We're up to 27 minutes. So we will continue doing some more of these inequalities on part B, day 32. So we're going to stop for now, and then we'll pick it up on another video.